Welcome all. I'm Dr. C. Jenny Tenancy, Assistant Professor and Head, Department of Mathematics, PPG College of Arts and Science, Coimbatore. Today we are going to discuss about measures of variation and standard deviation. Meaning of dispersion. Dispersion measures how spread out data values are around the average. Two datasets can share the same mean yet differ greatly in consistency. Now we are going to see an example of same mean and different spread. There are two groups, namely A and B, where group A consists of the numbers 48, 49, 50, 51, 52. Here the mean is 48 plus 49 plus 50 plus 51 plus 52 divided by 5, that is equal to 50. Here the numbers are very nearby to each other so that it has a low spread and the values cluster tightly. Now group B consists of 5 elements, namely 20, 35, 50, 65 and 80. This also has the same mean 50 by calculating as 20 plus 35 plus 50 plus 65 plus 80 divided by 5. The difference between each and every number is large, therefore it has high spread and the values scattered widely. Now we are going to see the common measures of dispersion. The first one is range, quartile deviation, mean deviation and standard deviation. Now we are going to see the measures of variation. The first one is range. It is the simplest measure of dispersion, that is the difference between the highest and lowest values in a data set. The formula is given as range is equal to highest value minus lowest value, and the coefficient of range is given as h minus L divided by h plus L, where h is the highest value and L is the lowest value. Now an easy problem. Marks of 5 students are given as 12, 18, 25, 30 and 45. Here we can clearly see that there are 5 numbers, and from these 5 numbers we can easily take out the highest value as 45 and the lowest value as 12. As already we know, the formula for range is highest value minus lowest value. Therefore, we can write 45 minus 12, which is equal to 33. Finally, we are going to calculate the coefficient of range, that is equal to h minus L divided by h plus L. That implies 45 minus 12 divided by 45 plus 12, which is approximately equal to 0.58. The quartile deviation, it is half the distance between the third quartile and the first quartile. Formula is QD is equal to Q3 minus Q1 by 2, where Q3 is the third quartile and Q1 is the first quartile. And coefficient of quartile deviation is Q3 minus Q1 divided by Q3 plus Q1. Now an easy problem. Here the data sets are given as 10, 20, 30, 40, 50, 60, 70, 80, 90. Here the number of items is 9. Therefore we are writing n is equal to 9. Now we have to consider the Q1 position, that is equal to n plus 1 by 4, that is equal to 9 plus 1 by 4, which is equal to 10 by 4, that is equal to 2.5 value. That is the numbers between 20 and 30 from the data set. Therefore Q1 is equal to that 20 plus 30 divided by 2, which is equal to 50 by 2, that is equal to 25. Similarly, we have to consider the Q3 position, that is equal to 3 into n plus 1 by 4, that is equal to 7.5 value, that is between the 7th value and the 8th value from the data set, that is between 70 and 80, which implies Q3 is equal to 70 plus 80 by 2, which is equal to 150 by 2, that is equal to 75. Since we got Q1 as 25 and Q3 as 75, we are going to write the formula for QD, that is equal to Q3 minus Q1 divided by 2, which is equal to 75 minus 25 divided by 2, which is equal to 50 by 2, that is equal to 25. Coefficient of quartile deviation is equal to Q3 minus Q1 divided by Q3 plus Q1, that is equal to 75 minus 25 divided by 75 plus 25, that is equal to 50 by 100, which is equal to 0.5. Now the mean deviation. It is the average of the absolute differences between each value and the mean. Formula is summation of x minus x bar divided by n, where x bar is the mean, n is the number of observations. Now an easy problem. The numbers are given as 2, 4, 6, 8, 10. Now we have to consider x bar, that is equal to addition of all numbers in X divided by total number of items, that is equal to 2 plus 4 plus 6 plus 8 plus 10 divided by 5, which is equal to 6. Now we have to consider the second column, X minus X bar. As we know already X bar is equal to 6. We have to consider the first element as X minus X bar, that is equal to 2 minus 6, which is equal to minus 4. The second element 4 minus 6, which is equal to minus 2, and goes on. The third column is the modulus of X minus X bar. Here only the positive values are taken from X minus X bar, which is the second column. If it is minus 4, the answer is going to be plus 4. If it is minus 2, the answer of the third column is going to be plus 2, and goes on. Now we have to take the formula, that is equal to MD is equal to summation of modulus X minus X bar divided by N. That is the consideration of the third column, which is equal to 4 plus 2 plus 0 plus 2 plus 4 divided by the total number of items is 5. Therefore, that is equal to 12 by 5, which gives an answer 2.4. Now the meaning and definition of standard deviation. It is the positive square root of the mean of the square deviations of values from their mean. It is the most widely used and reliable measure of dispersion. The formula for standard deviation is sigma is equal to root over summation of X minus X bar the whole square divided by N. And the variance is sigma square is equal to summation of X minus X bar the whole square divided by N. Standard deviation uses every single observation in the data set. It possesses same unit as the original data. It forms the basis for further statistical analysis, such as correlation and testing. Now an easy problem for calculating the standard deviation. X is given as 2, 4, 6, 8 and 10. Now we have to calculate X bar, which is equal to mean, that is equal to summation X by N, that is equal to 2 plus 4 plus 6 plus 8 plus 10 divided by number of items, that is 5, which is equal to 6. Therefore, we are going to consider the second column is X minus X bar. We know already the value of X bar is equal to 6. Therefore, X minus X bar is 2 minus 6, which is equal to minus 4. 4 minus 6, that is equal to minus 2. 6 minus 6, that is equal to 0, and goes on. Now we have to consider the third column X minus X bar the whole square. That is the square of second column elements, that is minus 4 the whole square is equal to 16, minus 2 the whole square is equal to 4, 0 the whole square is equal to 0, and goes on. Now we can see the totality of X minus X bar the whole square is equal to 40. Thus, the sum of the squares is equal to 40. Now we are going to consider the formula for variance, that is sigma square is equal to summation of X minus X bar the whole square divided by number of items, that is equal to 40 by 5, which is equal to 8. Such that standard deviation's formula is square root of variance, that is equal to sigma, which is equal to root 8, that is equal to 2.83. Now the coefficient of variation. It is a relative measure that expresses standard deviation as a percentage of the mean, which is used to compare consistency across data sets with different units or averages. The formula for coefficient of variation is CV is equal to sigma by X bar into 100, where sigma is the standard deviation and X bar is the mean. An easy problem is given below. Now coming to the properties, merits and limitations. Coming to the merits, standard deviation is based on all observations, not just extremes. Standard deviation is rigidly defined and leaves no room for ambiguity. It is suitable for further algebraic treatment. It is least affected by sampling fluctuations among common measures. It forms the foundation of the normal distribution and inferential statistics. Coming to the limitations of standard deviation, it is more affected by extreme values than the quartile deviation. It cannot be computed for open-ended class intervals. It involves more calculation than range or mean deviation. It is not easy to understand for a non-technical audience. Finally, we are coming to the applications of standard deviation. Standard deviation is a practical tool wherever consistency, risk, or reliability needs to be measured. It is used in finance and investing, quality control, education, weather and climate, sports analytics, and data science and AI. Thank you for the patient listening. Have a good day.